Welcome to Future Talk. Teaching children to be creative thinkers who can solve hard problems by themselves is essential to preparing them for the future. Public schools don't always succeed at teaching these skills, but my guests have something that may help. They're co-founders of a company called Piper, which makes the Piper Computer Kit, which enables young kids to build their own computers and program them. The company has already raised over $10 million in venture capital, and one of their early boosters was Apple co-founder Steve Wozniak. I'd now like to introduce my guests. Mark Pavlyukovskyy is the Chief Executive Officer of Piper. Mark was born in the Ukraine, educated at Princeton and Oxford, and was recently named to the Forbes 30 Under 30 list. He first got the idea of building educational tools while working as a biologist in Ghana, teaching children about public health. Joel Sadler, PhD from Stanford, is the Chief Technology Officer of Piper. Originally from Jamaica, Joel worked on special projects at Apple for Steve Jobs, and as a Stanford student, helped create an affordable prosthetic knee known as the Jaipur knee that is now used by tens of thousands of people around the world, and it was named one of Time magazine's 50 top inventions of the year. Gentlemen, great to have both of you on the program today.
It's great to be here. Thanks, Marty.
Now we're going to be talking about the Piper Computer Kit in just a minute, but first we have a short video that demonstrates how the kit is used. So let's go ahead and roll that video.
Kids are using technology more than ever on a daily basis. But how much of that technology actually allows them to do physical, tangible building? At Piper, our mission is to reintroduce building into kids' lives. And our first product is a computer kit that kids build and program themselves. What we try to convey with the product is giving kids this very basic looking kit, and at the end having them emerge with a fully working computer and coming away with this confidence and an experience that they'll remember for the rest of their lives.
Piper is teaching in a completely untraditional way. It uses a game and uses that digital block-based plane to actually teach kids things. We show them computer chips and circuits inside that world, and they are taught how to connect things to them and build things with them. We think troubleshooting is a big part of learning with computers, and debugging is a huge component too. We actually talk to the kids about their computers. They can call Piper and we'll troubleshoot with them. We put a lot of thought into these computers and want to make sure that the kids who are using them are getting the most out of them. Anyone can build and anyone can create, and there's a growth mindset that comes from achieving more and more and more as you grow up as a kid. So we are building infused with that research and that idea that this is the way kids should be learning.
Teaching kids technology is extremely important today because it's really giving them the fundamental problem-solving skill to take something that's nothing and turn it into something that can be useful. So the Piper computer really helps them want to succeed.
Our goals are to create a full ecosystem of products that empower kids all over the world, all age ranges, to build whatever they want. Getting that understanding that they actually have power, they have autonomy, they have confidence, and they can build other more complex things. It's completely yours to make yours.
And that was a quick introduction to the Piper Computer Kit. Now, Mark, why is the Piper Computer Kit needed? What lack is it attempting to fulfill?
Yeah, thank you for having us, Marty. It's great to be here. You know, today we look at how kids play, and it's very different from how kids played when I was a kid. Technology is all over the world. We interact with it every single day of our lives, and actually, kids spend on average 6 hours a day looking at screens, having screen time as part of their life growing up. And we believe that it's important from a young age to show kids that technology isn't just something you consume. It's something that you can actually mold to be yours and something you can create with. We grew up playing with Legos, and Legos showed us that you can build what was on the box, you can follow the instructions, but you could also then take it apart and build anything else. You can let your creativity roam free. And we feel that a lot of the products and apps that kids play with today are very focused on this consumption mindset, very passive experience of just consuming content from iPads, from phones, from computers.
So do you feel that schools don't teach kids how to be creative thinkers? They teach them how to memorize stuff, but as far as tackling a problem that requires a lot of persistence, maybe you're not going to get that in public school.
Exactly, and I think what parents are also realizing is that to prepare their kids for the future, it's not just about memorizing facts. It's about understanding how to solve problems in a way that maybe you've never seen before, right? Any piece of information you want is at your fingertips today because of Google and other platforms like that. And so what's important is teaching kids things like grit, like confidence, like problem solving, like creative thinking. Those are the skills that are going to allow kids to succeed in the future.
I noticed that girls were featured prominently in that video. You're trying to make a special appeal to girls, considering that girls often seem less attracted to careers in technology than boys.
And I think this is something really important to point out in how we design the product. We wanted to design inclusively for all. And so whether it's girls or boys or whatever race or country you come from or socioeconomic background, we want a product that is a universal teaching tool. And we want our product to reflect that in its values. And that's why we put that out there when we make videos.
Now, how does the product actually work? You have a box right there, so that is the assembled product, right?
That's right.
Maybe you can just like open that up and we'll
Sure, and I should point out that this box is the end product of a building experience. The actual core experience of Piper, it starts with jigsaw puzzle-like pieces of wood. There's a screwdriver, there's nuts and bolts. You have to use your hands, and you have to follow some schematics in order to create what you see here. So I really want to stress this is the end result of somebody's first time they're building a computer. And maybe for many of your viewers, they can remember the first time that they built a computer and turned it on. That's a feeling that we're trying to replicate and scale for today's children.
And what's the target age you're going for?
This is age 7 to 12. And it's really important that early age group before they sort of exit their critical formation period and come up with predefined notions of, you know, if I'm good at math, or am I good at math, or am I not good at math or science? And we start to hear these ideas bubble up at this critical age, and that's why our company focuses on this age group, because we find that is where we'll see the most impact. If we prevent children entering into an education system that might not always foster that sense of empowerment.
So you want to get them started on the right track early.
And this represents the right track for every child that builds a Piper. That we think that's the first step. And so this is sort of a symbol for us when you see this box on somebody's mantle and you walk through the door, maybe you're a guest, and the child comes up and says, look, I built this computer. So that's what I want to say. This isn't the computer is not what we build. It's the learning experience and the pride that comes from overcoming something that you didn't think you could do before.
Well, let's see what it looks like.
Yeah, so this is sort of a wooden box, and on the inside, this one's already turned on, and we can see that on the inside, we're exposing the computer, right, from the inside out. There's a Raspberry Pi computer that is sort of the brains of the kit, and the kit sort of comes with the real components that engineers that I use in my work and in my studies and in my play to build real inventions. So these are wires, and there's buttons and buzzers and sensors, and it all comes together into a fun learning experience that's wrapped in a game.
So we actually have a still image, which maybe you'll get a slightly better view of what's in there. Can we see that image, please? It's actually, there it is. Yeah. So that pretty much shows all the parts. So you have the central processing unit. That's the Raspberry Pi, spelled
That's right.
P-I. So they're wiring it. They're following the blueprint to wire it all together.
Yeah, so maybe to jump in and kind of explain a little bit more deeply, what we realized from talking to kids and experimenting a lot with the different products was that kids needed to have something that was hands-on. Hands-on building was really important, but they also needed to have something that engaged them on the software side, something on the screen, something that they were already used to. And for us, that was actually Minecraft, this really popular game, in fact, the most popular game in the world today. And through the Minecraft gameplay that we've designed, we actually guide kids to build electronic components, switches, wires, and actually program them as they're playing. So this augmented experience of you're playing on the screen while you're simultaneously building the physical controls. And as we showed you earlier, first thing you build is actually the button to move forward. And that, what we've noticed is that really motivates kids. If you can't move in the game, you really want to figure out, how do I build the button to move? The next thing is you want to find the treasure. You want to find diamonds. Diamonds is a key resource in Minecraft. You build an LED light, so an actual physical light. You hook it up to the computer, and that shows you the closer you get to the diamonds, the faster it blinks.
So once you assemble the computer that you've just started, right, then you get into the game, which gives clues about how to add more components and more capabilities.
That's right.
And that's exactly the key idea, that we want the computer to help guide you to build more of the computer and more things beyond the computer. And I think the video game piece that Mark's bringing up is really key, because this is a 3D world in which you can touch blocks and remove and add, and it's essentially what we always wanted as kids in Legos, to be able to imagine and then create. Well, that's here now, and millions of kids play this game every day, and it was perhaps one of the most important things that we learned, was to include that as a part of the product, to give a sort of Trojan horse type learning, where we wrap this in something we knew children would be excited to start out with, and then give them a deeper insight.
I think we have a graphic image of what one of those games look like, if we can bring that up. There it is. All right, so this is inside one of the games, and presumably in the real game things would be moving and you would be controlling things. And
that's right, and it's a three-dimensional world, and I think a lot of people are often surprised about this low-resolution, blocky-based aesthetic. We find that our users love this kind of a world. You know, we think it comes down to looking at something and feeling like you can change it. We want to create innovators. We want to inspire people who are confident to reach out and touch the world and make a dent. And I think that these kinds of worlds, from the moment you enter them, with a single click, you're modifying the world, and that's an idea that we amplify, not just in the virtual world, but also in the physical world.
Now, is this being used as an educational tool, in addition to parents buying it for their kids? Is it also used in schools where people can use it in an official learning experience?
Yes. So one of the really important pieces for us in terms of bringing Piper to kids all over the world is the level of impact and reach that we have. And one of the ways we do that is through schools and through bringing Piper into classrooms that teach computer science, engineering, technology, coding. And we notice that in a classroom setting it works really well, because in the beginning you have to actually physically build a computer, and it works really well for a collaborative experience. So teachers love that, because you get kids in groups of 2s and 3s collaborating, building, trying to figure out, how do I put the computer together, problem solving together, right? These are skills that it's very hard to sort of present in a regular classroom setting. This experience allows them to do that. And then after that, as they actually begin playing the game, it's the same deal. It's more collaboration, it's more critical thinking, more problem solving, and there's lessons built in throughout the experience that a teacher can stop the classroom, stop the lesson, say, hey, what are we learning? Are we learning about circuits? Are we learning about coding, for loops, all the different pieces of the technology stack that you need to know about, from the hardware to the software, Piper includes. So we actually have thousands of kids using Piper in schools today to learn about technology from the ground up.
So in a school, is there one Piper and it's used by the whole class, or if it's a wealthy school district, maybe they can all have their own?
Well, you know what? We really liked the idea of one Piper for every kid, but it turns out that when we go into schools and give Pipers, it's not the ideal. We find that when you have multiple children collaborating around this building experience, they're sitting on the floor, sometimes with the teachers. We're usually there with them. That's some of the most rewarding parts of our days, actually seeing users in schools make these, and that collaboration piece is really key, and that's something we've learned over time, that this working together is a really important educational learning goal for us.
Now, what got you started in this? I know that you were living in Ghana for a time, and you said that your experience in Ghana led to your designing educational tools. How did that work out?
Yeah. I mean, my story sort of goes back to I was born in Ukraine and moved to America when I was 9. I was pretty young. And growing up here, I realized that I got a ton of opportunities here that my peers in Ukraine weren't getting access to, whether it was mentorship or going to Princeton, going to Oxford later. And I wanted to give back in some way. I was majoring in biology at the time, and I decided maybe I can empower kids in a place like Ghana to teach them about global health. That's what I knew about. I knew about biology, how to prevent diseases, and I thought maybe I could combine that with games and teach kids through games how to prevent malaria, other types of diseases, and hopefully inspire them and empower them for a better life. And that's how I sort of began to try to change the world in a small way, and that sort of took me off on this mission of building Piper. The way that happened was being in Ghana, I actually almost had to be evacuated. I almost died in the process. I got sick, ironically, and that experience made me realize to enact change, I needed to do it in a more scalable way, something that probably involved technology, programming, learning these skills. So I taught those skills to myself, learned them, and realized it wasn't very difficult to do. There was books. If you followed the books, if you learned, if you practiced enough, you could do it. And I figured if you could do it from a younger enough age, you could be creating really, really great technology. So the vision for Piper and the initial kind of products that we designed were something that a kid as young as 9 could play with and could be inspired to be in programming, building with technology, something that I wished I had growing up.
Well, education is in a big flux in this country. The educational system is resistant to change, to say the least. It's a big bureaucracy. They want to teach things that can be quantified and measured, like how well you can memorize things. Measuring persistence is kind of hard, but so we are thinking about how to reorganize that. But Joel, how did you get involved? I understand that you spent some time in India and helped develop a prosthetic knee because there was a big need for less expensive prosthetic knees.
Yeah, I think for me, growing up in Jamaica, coming from a very cost-constrained environment, a lot of my work has involved figuring out ways to do extremely affordable tools for everyone. And so you can see that in sort of how we get here with Piper. We want everyone to be able to create. And so my experiences with prosthetics was in India. It was really valuable because it taught me the value of designing something physical that can directly impact someone's life in such a deep way. And so meeting Mark over Piper was I immediately saw, hey, if I want to invest in the future and to make the biggest impact possible, one of the best investments anyone can make is in the children of the future. And so that's when I was sort of hooked, and we teamed up to make the product as you see today.
Now, usually any company can't sit still on one product. You have to have a new version of it, and you have to have additional products. What do you have in mind for the future?
Yeah, I mean, like we were saying earlier, the insights for Piper came from kids telling us they wanted to play Minecraft, and we thought, how do we combine playing Minecraft with learning about technology and actually creating with technology? And so right now we're exploring a lot of different avenues for different product types. We're prototyping, and we'll have a few products coming out next year. But just to give you a sense of how we think about product development, we think about it from the point of view of the kid, of the children that we're actually bringing the products to from the users. And so we think about, what do they want to do? What do they want to play with? And then how do we deconstruct that technology and make it something that's accessible, that they can create themselves, they can modify, they can program, and they can make their own. We feel like that's the fundamental difference about the products that we make, is that you have technology out there, most of it works through magic. It's sort of like a black box device. Kids use that technology. Technology we create, you actually create along with us. You actually make it your own.
I noticed that the kit doesn't have a keyboard. Is that because there's no need for a keyboard, or is that a limit? Like, we're also used to using keyboards. Maybe the computers in the future, you don't need a keyboard.
Well, that's a great observation, Marty. We debated early on whether or not we should include a keyboard, and we actually decided to take it out because we actually wanted the first experience of the first 2 minutes of playing Piper to be building your own keyboard. We had this whiteboard inscription in one of our early offices in a tiny mailroom in the basement that sort of said something along the lines of anything you want, any technology you want to use, you have to build yourself. And that ended up being a very useful guiding philosophy when we were looking at the keyboard, because it turns out that a keyboard encompasses the fundamental ideas of a sensor, that when I do something, it enacts change somewhere else, and it's regulating the flow of energy from one place to the other. And we're really proud that every child who plays the first 2 minutes of Piper and connects wires up directly to the chip and touches them together and sees that their character moves, each one of those children has developed an intuition about what a keyboard is made of, which is just a scaling up of this one simple idea. So we thought that was really important to give that first experience. And by the way, if you want a keyboard, you can plug in a keyboard and code away.
So are there any limits to the device? Like, how long will a child play with it before they say, well, I've gotten everything out of this that there is to get out of it? Many kids, they play with a toy for 10 minutes and it's discarded. And this is considerably longer than that, but at what point have they gotten everything out of it?
So one interesting insight that we got when we showed this to, sent this to Steve Wozniak actually, and his quote to us was, Piper represents all the technology things that allowed me to do what I did in my life. Sort of the essence of hacking a game that's how he got started with technology. He was hacking arcade machines. He was hacking early computers, because he wanted to play games and you had to put in coins to play, so he would hack them, right? And so the idea here is to give kids the way we think about it is a boot camp. There's a bunch of content that we create, tens of hours of content that kids go through, but then from there on, it's an open playing field, and kids can actually create with Piper whatever they want. It's a fully working computer that they've built, that they understand how it works, and there's really no limits, right?
And the interesting thing on our end in terms of users interacting with our product, we have guided, scaffolded lessons that sort of say, look, plug in these wires in these places and see what happens. Build this button, build this controller, see what happens when you hook up an LED, can you make it light? So we've built in strategically these moments of learning that sort of, in a gentle way, introduce core fundamental concepts. And those are separate from what we really want to see and what we really enjoy seeing, which are kids expressing themselves naturally in the world with their natural creativity, building, in some cases, inside of the game, and in other cases outside in the circuit world.
Not being fearful of it, being confident to be hands-on.
Yes, and the word confident, I think, is a real key one here, because we build a piece of technology here, but what we're really trying to get at is a sense of creative confidence. That's the most important thing that we want to get out there when someone interacts with our product. The technology is just a means to get to that increased sense of creative confidence that I can build what I dream.
Well, I understand you're one of the top-rated STEM products on Amazon.
Yeah, and we've luckily gotten that title over the last...
STEM meaning science, technology, engineering, and math.
That's right, that's right.
We like STEAM with the arts in the middle.
Yeah, and we've seen that there's a lot of products in the market that try to focus on teaching kids programming, electronics, building of different types. And I think the reason we've gotten that title and that accolade was because we sort of understood something deep about what our users, the kids, actually wanted to do with the product, which was they really want to have creative freedom. They want to have fun. They want to have an experience where they can make something they're proud of, right? And that's at every single stage in the product life cycle, we have that beautiful experience, whether it's them building a computer or building a keyboard or building switches and lights, and they're doing it all through the storyline in the game that they already love playing. So I think, for us, it's just following that philosophy of how do we create the most magical experience for our users to empower them. That's what kind of led us to winning.
So do you test market with actual kids? You design something and give it to these kids and play with it and get the feedback?
Yeah, that's a great question about our process. I mean, we find that the core insight to put this game inside of the product, it didn't come from us. I had never played the game Minecraft before. It came from talking to kids and asking them, hey, what do you think about this prototype that we put in front of you? What do you want to do with it? And a resounding, if you go into a classroom in any part of the world, I'd guarantee that you'll hear Minecraft come up at least once. So this was our clue to dig deeper, and our process at Piper involves weekly to be in touch with our users. Everything that we build, we make sure it goes through the lens of the child, as well as the broader ecosystem of parents and educators and so on. We find that this keeps us sort of refining the product and keeps us sort of building that user experience that is magical.
We just have about a minute left. Can you talk about any major changes you hope to make, without giving away any proprietary information, of course, give your competitors an advantage, but any clues as to the overall direction, like more engaging, more programming?
Well, I think, and Mark touched on this a little bit earlier, we have a method that we use that is, we want to listen to kids, but we also want to get them building really interesting and beautiful things that they have inside that they want to build. So our future products will build on those ideas of coding and electronics and physical building in ways that we hope will surprise and delight everyone.
Anything you'd like to add in the 30 seconds we have left?
I think we see a huge change with the way kids are interacting with technology, with the world around them. And we believe that it's really important for us to give kids a sense of confidence in this high-tech world. We believe that, you know, automation and programming and all these things happening in the world, kids need to feel like they understand technology, like it's theirs to own.
We're going to have to leave it at that, unfortunately. Thank you for watching. I've been speaking to Mark and Joel. We've been talking about the Piper Computer Kit. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman, and we'll see you next time.